Hello everybody, what is up? I hope everybody's had a wonderful day today. It is your boy Trix, and today we're going to be doing some more Rust Rogue, which you can see on the left hand side. But we are going to start with some wrestlings. So if I do wrestlings verify, I believe. And this just goes through all of them so I can see which one I haven't done. And that means functions. So if I vi and then go to functions, so it looks like we are going to be doing these 5, and then we're going to do the next 5, well, next however much afterwards. So I'm not done. Okay, so I believe if I do fn call me 10, is that right? Yep. Cool. Let me just check that. Yeah. So all I did was make a function that literally does the exact same thing. I'm pretty sure I could have just removed this and then it'll still run, right? If I do rustlings verify, yeah, it'll still run. Exercise expected type. Okay, so call me. So this should just be an I. Actually, I could just do an I8, right? I'm pretty sure I8s exist in Rust, or it might just be I16s or I32s. Yeah. For context for why I've chosen I8 instead of I32 by default is because, well, if I go into the code, actually, let me just run rustlings hint functions too. Yeah, it's just expecting any type of annotation. So if I go into exercises, functions, and then functions too, for context, I is just integer, and then 8 is the amount of bits that can be that can be occupied within that integer, right? So if you use u, it means an unsigned integer. If you use I, it means a signed integer. Just for context, so unsigned 8 is just 256. Any number from 0 to 255 or 256, from 0 to 255. Sorry. That's for unsigned 8. For a signed 8, it would be negative 128 to 127. I'm using I8 because it's just a common number, and because it fits 3. I'm pretty sure you could do what's the signs? Rust integer types. I know there's I8, U8, I32, U32. Yeah, I8, U8 to I28, U28. I mean U128, sorry. And the default for an integer is just I32. So I could swap that I8 to just int and it will default to I32. It's the number of bits that integer can occupy, basically. And I've purely done that just because. Save memory when you can. if it's not necessary, don't overuse memory. Okay, so call me U32. Oh, it just expects a number. Okay, so if I just do a 1. Yeah. Oh, I didn't even read that. Hang on. Expected type found. Expected type. Oh, that's just a return type. Oh, whoops. So we have an original price, right? Which is 51. This goes into sale price. Oh, here we are. The store is having a sale where if the price is an even number, you get 10 brush bucks off, which is just the -10 on line. Relative numbers, sorry. If I go 14J, that is just this bit. And then if I go 14K, just back up. But it's an odd number. If it's an odd number, it's $3 off, which is line 16 down. There we are. And then 16 up. Don't worry about the function bodies themselves. We're only interested in the signatures for now. If anything, this is a good way to peek ahead for the future exercises. So literally all we're going to be doing is just returning the I32. We could optimize this a little bit by changing it to an I8 because an 8-bit integer should be able to fit 51 all the way to 100. But it should be fine. I'm assuming they done an I32 just because it's normal to normally just look at int type to be 32 bits anyway, so fair enough. If I run this, I should really start using Control R. Yeah, cool. Oh, whoops. Cool. I really need to read it before I go in. Okay, so square to an I32. Expected I32 found nothing. Implicitly returns an expression as body has no tail or return expression. Help remove the semicolon. Oh yeah, you could either just slap a return in front of that, or you can just remove the semicolon at the end. I'm pretty sure you can just slap a return in front of that. Yeah, you can just slap a return in front of that. Let me just check what it wants you to do. Hint functions 5. Yeah, there are 2 solutions. You either slap a return or you just remove the none times. So to show the other way you could do it, you could delete that, delete this, and then whoops, and then you can just run it, and it'll just be able to know to return that instead. So the way to think about it is in Rust, you do not always need a semicolon at the end of a line, right? So for example, if I go to what's a good example in here? Is there one in here? Functions 4 has a good example. Okay, so you have this line 12 and line 13, right? They both have semicolons at the end to signify the end of a line, right? That's completely fine and completely normal in most cases. Then, if you notice on lines 18, 20, and 25, there aren't semicolons at the end, but they are still returning that statement, that expression afterwards. So it's just evaluating the expression and then returning it, right? So what I believe happens is if it doesn't have a semicolon at the end, it'll just assume that you're trying to return that bit of logic, and that if it does hit that block, it will just ignore everything below it and just return straight from there, right? If you, in normal languages, I say normal languages, in like Java, C, C++, even in Python, you just write return whatever, and then in Java, and in, I'm not going to say statically typed languages because Python kind of does it too. You can use Python with semicolons, but in languages that are curly brace languages, for lack of a better word, you would use a semicolon to signify the end of a line just by default, and you'd use a return. In Rust, you don't really need to write a return. It's useful if you write the return anyway, just because you know that, hey, this is where the this is where control flow ends for this area in the code. But other than that, you don't really need to use it. I prefer writing it just because I'm coming from Java and languages that commonly use return. But I know lots of people like the simplicity of Rust where you don't need to write it. I know in the games tutorial that we're doing, it doesn't actually use return all that often. Yeah, so like here, you could, when you're doing this, where it has this digger x1, this is just returning an expression, right? You technically do not need a return in a map. Sorry, I'm just seeing a random little fly around, but you can specify it. But if you use a return, you need to have that semicolon at the end. It's just in pattern matching and match statements, which is basically just switching Rust. You do not need to use a return, just because it implicitly knows that if there isn't anything to execute afterwards, that you're going to return it anyway. That's why if you go to the end here, it's using a lambda to specify that this is the thing you want to return. And because your next statement is just another matching, another case to match on, it just knows that it should just ignore everything else. Anyway, if I press things verify, I don't know if I removed it from functions 5. No, I didn't. I keep forgetting. There we are, functions 5, and then cool. And then if I do Rust things verify, nice. We're on if statements now. Now we're going to switch to some Rust Rogue, just so I can get some Rust Rogue in, and then we're going to switch back to Rustlings after doing some Rust Rogue. Cool. So if I cd into Rust Rogue, there we are, and then I'll just vi for a bit. Let's start in mod. I know I'm going to have to touch it anyway, so might as well just start it. Okay, so diffusion limited aggregation is a fancy name for a constrained form of the drunken walk. It makes organic looking maps with more of an emphasis on the central area and arms coming out of it. With some tricks, it can be made to look quite alien or quite real. See this excellent article on Rogue Bassin. Create a new file called DLA-RS. So in here, DLA-RS. There we go. And then put the scaffolding in from previous projects. We'll name the builder DLA builder. We'll also keep the Voronoi spawn code. It will work fine for this application rather than feeding the scaffolding code blocks from previous chapters. We'll just jump right in. If you get stuck, you can check source code from the chapter here. Thank you. Because that's the only thing that I kind of don't like about this tutorial, but still appreciate about this tutorial. It assumes you know what you're doing, which is great, because by this point, just reading Rust, you should be able to just understand what it does just knowingly. But then at other times, it's like, okay, like this about the scaffolding. It's fair to say, hey, just copy over the scaffolding from the other projects. But again, the scaffolding is very different between the projects. Well, you still have the same struct and implementation, but the builder is different between all of them, especially the one in Drunken. So again, I do appreciate that the author at least like links to the documentation. I mean, to the chapter that you're supposed to be looking at, because then at least moving it over is a lot easier. Just grabbing this. I'm probably not going to need to look at it again. I say that, I'm probably not going to need to look at it again. Anyway, algorithm trunking. In the latest chapter, we introduced the idea of adding parameters to our builder. We'll do the same again for DLA. There's a few algorithm variants that can produce different map styles. We'll introduce the following enumerations. DLA algorithm, which is here, and DLA symmetry, which is here. Our builder will include one more brush size. This should be pretty self-explanatory by now if you've been through the other chapters. We're supporting 3 algorithms: walk inwards, walk outwards, and central attractor. We'll cover these in detail shortly. We've added symmetry, which can be either none, horizontal, vertical, or both. Symmetry can be used to make some beautiful results with the algorithm, and we'll cover that later in the article. We'll also added brush size, which specifies how many floor tiles we paint onto the map in one go. We'll look at this in the end of the chapter. We'll include floor percent from Drunkard's Walk chapter. Our new function needs to include these params, that is down here. We'll make some type constructors once we master the algorithms and variants. The most basic form of diffusion limited aggregation works like this. Dig a seed area around your central starting point. While the number of floor tiles is less than your desired total, select a starting point at random for your digger. Use the Drunkard Walk algorithm to move randomly. In the digger, hit a floor tile. Then the previous tile they were in also becomes a floor and the digger stops. Very simple and not too hard to implement. Then the build, which is... it's an implementation, there we go. The only new thing here is the paint, which is... there we go, paint. We'll be extending it later, handle brush size, but here's a temporary implementation, which is the paint method. There we go. If you cargo run this, you'll get a pretty cool looking dungeon. It's slow though. Well, I say slow, not really slow. It's probably just because it's loading. Second variant of this algorithm reverses part of the process. Dig a seed area around your central starting point. While the number of floor tiles is less than your desired total, set the digger to the starting central location. Use the Drunkard Walk algorithm to move randomly. If the digger hit a wall tile, then that tile becomes a floor and the digger stops. So instead of marching inwards, our brave diggers are marching outwards. Implementing this is quite simple and can be added to the match sequence on an algorithm build. So walk outwards is this one. There aren't any new concepts in this code, and if you understand Rogue's Walk, it should be pretty explanatory. If you adjust the constructor to use it and call cargo run, it looks pretty good. Central attractor. This variant is again very similar, but slightly different. Instead of moving randomly on particles path from a random point towards the middle, dig a seed area around your central starting point. While the number of floor tiles is less than your desired total, select a starting point at random for your digger, plot a line to the center of the map, and keep it traverse the line. If the digger hit the floor tile, then the previous tile they were in also becomes a floor and the digger stops. Again, this is relatively easy to implement. This is just this one. If you adjust the constructor to use the algorithm and cargo run the project, you get a map that is more focused around a central point. Implementing symmetry. Tiger, burning bright in the forest of the night, what a mortal hand or eye could frame thy fearful symmetry. I've never heard this before, but okay. Symmetry can transform a random map into something that looks designed but quite alien. It often looks quite insectoid or reminiscent of Space Invader's enemy. Space Invader's enemy. This can make for some fun looking levels. Let's modify the paint function to handle symmetry. So down here, there's gonna be one. Okay. There's a long function that it really needs to be. This is a longer function than it really needs to be. In the name of clarity, here's how it works. We match on the current symmetry setting. If it is none, we simply call apply paint for the destination tile. If it's horizontal, we check to see if we are on the tile. If we are, just apply the paint once. Otherwise, obtain the horizontal distance from the center. Paint at center x minus distance, center x plus distance to paint symmetrically on the x-axis. If it is vertical, we check to see if we are on the tile. If we are, just apply the paint once. This helps odd numbers of tiles by reducing rounding issues. Otherwise, obtain the vertical distance from the center. Paint at center y distance and center y plus distance. If it is both, then do both steps. You'll notice that we're calling apply paint rather than actually painting here. That's because we're also implementing brush size. I'm pretty sure I was going to say something. This both bit can be simplified to just calling back on paint with the symmetry type. So you could just do self dot apply paint with what's it called? Oh, are they not passing in? They could override symmetry. You could override symmetry, or pass in a new symmetry object and then pass that through. But I don't know if this has method overloading. Interesting though. Yeah, that's that we're calling apply paint rather than actually painting. That's because we also implemented brush size. Yeah. It's quite simple. If brush size is 1, we just paint a floor tile. Otherwise, we loop through the brush size and paint performing bounds checking to ensure we aren't painting off the map. If your constructor used the central attractor algorithm and enable symmetry with horizontal, if you cargo run now, you get a map not unlike a cranky insectoid. Playing with the brush size, using a large brush Using larger brush ensures that you don't get too many 1x1 areas that can be fiddly to navigate and give a more planned look to the map. Now that we've already implemented brush size, modify your constructor like this. Okay. Rather than pollute the random builder function with the algorithm details, we'll make constructors for each out of the major algorithms we use in this chapter, which are up here, which is walk inwards, walk outwards, central attractor, and insectoid. Yep. Now we can modify a random builder in the map mod RS to actually be random once more and offer even more types of maps. So if I go into here, I'm just going to grab mod, just because grabbing mod is easier than me typing out everything. There we are. So if I go into mod, BGP, there we are. Cargo build. Interesting, my chat is being funky. On OBS at least, I can kind of see one, and that's about it, and that's just stream elements, so yeah, it's fine. Cool, so if I cargo run, sorry about this, you're gonna hear some static. There we are. This is not the one that we just made, I can tell, but it's okay. This is just to make sure that the map built correctly. Ah, there was a bear trap, sick. Do I have weapons? No, but I do have rations. So that's the only thing I got for me right now. Okay. Cool. Chapter 30. Diffusion. Limited. Station. There we go. Scaffolding. Algorithm tuning knobs. Walking inwards. Walking outwards. Central attractor. Implementing symmetry. Playing with brush sizes. Providing a few constructors. Chapter 31. Adding symmetry and brush size as library functions. Whoops. There we go. So if I see you back to rustlings, long day, guys. Rustlings verify. Cool, we're now on if statements. So if I VI into if statements, we have two to do. Interesting. So execute rustlings hint F1, if one, sorry, or use hint watch subcommand for a hint. Complete this function to return a bigger number. Do not use another function call or additional variables. So, okay, it's just, I'm pretty sure it is A greater than B, A colon B. Well, that's how you would do it in... That's how you use a ternary operator. I don't know if the ternary operator will work in Rust. Nah. Damn. Rustlings hint F1. Okay. Some similar examples from other languages. Yeah, my man. I literally wrote that. If condition does not need to be surrounded by parentheses. If else conditions are expressions, each condition is followed by a... Oh, so you just write it like how you would. Oh, hang on. I wonder. That should make a difference, but if it does, that's going to be weird. Yeah, it didn't make a difference. Interesting. Does it prefer the Python way? If it prefers the Python way, I'm just gonna write it the normal way. If A greater than B, right? A, and then this is just gonna be B. For context, why you do not need an else statement in this scenario, basically, this condition makes it that the only other option for this, if A is not greater than B, will just be to return B anyway. So you don't need the other else statement. That's all. Let's see. Step 1, make me compile. Okay, so looking at foo if viz, string to a string, if fizzish equals fizz, get foo, otherwise get bar, get the bar for buzz default to baz and default to baz test running. Okay, so let's have a look. If there's an else, if so fizz is foo, then fizzish equals fuzz. I want a bar, otherwise I want a baz, right? Yeah. Well, I didn't even care about the first one. I'm just wanting to get the test passing, so. Cool. Ooh, it's the quiz. You know what? I've only been going for 37 minutes. I want to hit at least an hour-ish. So you know what? We'll do the quiz. Ugh. Okay, so this is a quiz for the following section: variable functions and if. Mary is buying apples. The place of the apple is calculated as follows: an apple costs 2 rust bucks. If Mary buys more than 40 apples, okay, so hang on. So this needs to return I32, right? Cool. So if Mary buys more than 40, so okay, so hang on. So this takes a buying apple price, so the price, which is an I32, right? So apple costs 2 rust bucks. If Mary has more than 40 apples, right? Each apple only costs 1 rust buck. So if price, ooh, wait, hang on. That's number of apples. So number of apples, right? So if number of apples is greater than 40, then whatever, right? So let price, let cost I32 equals 0, right? I'm gonna make this mutable. Then I'm gonna make cost if, let me change this to a 2. Cost equals 1. So that's just number of apples times cost, right? I'm pretty sure. Unless I read that wrong somehow. Yeah. Are there really no hits? Nice. I'm also pretty sure I can optimize this a little bit. So I could change this to an I8 because I know that the values are going to be less than 8. I mean, they're going to be less than 156. So I8, right? Actually, 65 times 1 is just, yeah, they're going to be less than 128 because you can't get a value greater than, if it's 40, if it's greater than 40, then you're always going to have just 1, right? And if the highest assertion there is just 65, then the highest number that you can get would be 40 times 2, which is 80. So I8 should work. And then I could make this non-mutable, but then I'd be allocating more values than are necessary. And then cost if numbers... No, that seems fine. That should pass anyway. Yeah. Cool. It's only been 42 minutes, so I'll go for another 20 minutes, hopefully. Twitter event I found, keyword if, expected one of that. Okay, so if we go into primitive types. Primitive types has 6. Nice. No hints, there's no tricks, just get used to typing these. Fill in the rest of the line that has code missing. Okay. So that's true. Oh, okay. Wait, hang on. Yeah, I was gonna say, you don't need to define... You don't need to specify that as a bool there. What you can do is evening equals false. In general, you should be defining types, but you don't need to. Just like using var in Java. If you don't need to, you don't have to. But obviously, if you know that you're not going to have a value that's bigger than a certain amount, you can just optimize for that. It just means you're not wasting as much memory. Instead of... Because, okay, the way to think about it is the compiler, JVM, everything is smart to a certain degree, but that's after multiple times of iterating of the same variable, getting it to run. If it doesn't iterate multiple times, that optimization is not there. Yeah? And the allocation in memory will just allocate as much as possible based on what it sees fit, right? So you'll want to do as much optimization as possible beforehand, so that when your application actually does run, the JVM runs even smarter, and the compiler runs even smarter to do those optimizations when it converts it to bytecode. That's all. Fill in the rest. No hints. There's no tricks. Just get used to typing these. Character char. No single quote that are different from double quotes. You've seen this. You've been seeing this around. Oh, okay. Well, your character equals, and then we're just going to do like a $sign, right? Wrestling's verify. Oh yeah. Again, some places in Rust is like kind of like Python, and other places just aren't, and it's like Java, and then I'm like, oh yeah, it's like Java and C++. You gotta remember to put that semicolon in. Yeah, cool. I'm pretty sure we don't need to do other characters for that. We know what characters are gonna do. It should be fine. Well, it should be simple. You just... It should be able to grab len on the string. Yeah, if I do... Oh! I didn't know you could do that. So in Rust, you can do this, right? And then you can do like 10. Well, let's just do 100, right? Damn. Okay. So that's just initializing the same object, but 100 times in this to get an array that's 100 times long. That's sick. Nice. Let me just verify. Primitive types number 4. Okay. Oh, I know how to do this. It is pain. It is A, and then you want 2 to 4, so it's 1, 2, 3, I think. Ah. Trait size is not implemented for integer. All local variables must have a statically known size. Help unsized locals are guaranteed as unstable feature. Corresponding borrow here. Yeah. Ah. It's not inclusive. So that's 1 to 3, right? So that's 0, 1, 2, 3. You need to do 1 to 4 because it's not inclusive. Which makes sense, it's like a for loop. There we go. Let me just check that's what I wanted me to do. Anyway. It's because you can solve these in multiple ways that I want to like check what the hint is after I've solved it to make sure I've done it the right way at once. I'm pretty sure you can just do name age, right? It's like the extracts in Python, I'm pretty sure. Ah. You can do the same thing in Python, where you can have like a function return two elements if you wanted to, and you can like extract them both into the thing. But I've never seen it done with objects, because technically cat is now an object of string, comma, float. So, still very interesting. Oh, whoops. Yeah. Ah. Oh. It doesn't want it by... Well, it makes sense because I'm not modifying it. I'm not actually doing anything on the original one, where, like, with the slice, I was slicing the actual array and then returning it, so I was doing an operation on it. With this, I'm not actually doing an operation on it. On the original array, on the original tuple, I'm just accessing an element inside the tuple, so it makes sense why it doesn't want it. I just want to check that I've done those correctly. And then 6. First things verify. We got a little bit more time. Cool, Vex. How many are in vectors? No, there's only 2. I can probably get that then. Okay, so your task is to create a vector which holds the exact same elements as an array as in the array A. Make me compile pass the test. Execute Rustling's hint vex1 to do it. with the macro for vectors. Interesting. I'm not sure. Vec x1. One way to use the vec new function to create a new vector and fill it in with the push, or use vec macro and define your elements inside the square brackets. Well, it wants me to use a macro, so I would use that macro and then do and a, I believe. No, I wouldn't do and a. V change, it would be vec dollar this and then a. Verify. Interesting. What did it want me to do? Exact same elements, okay. But it wants me to return an I32 and an I32 with that and a vec of I32. Oh. It was with an and, I believe. Because all this is doing is storing this array inside of a vector instead of storing the elements of the array inside of a vector. No. What am I doing wrong? Interesting. Vex1. When that loads. There. Yeah. That's not what I wanted to see. Because if I was just typing it in, all of them, then that's easy. You just type in the numbers. I wanted to see how you'd actually do it based on the original array. That's annoying. So does it literally just want... Nah. That's so dumb if it wants me to do... Does it seriously just want me to do... That seems very wrong. Oh, of course it's not vect. Why did I put a T there? Yeah. Vec of even numbers is given. Your task is to complete the loop so that each number in the vec is multiplied by 2. Make me pass the test. Execute rustling hints v2 or use the hint watch subcommand for a hint. Okay, so I am not done. So to do, fill this up so that each element in v is multiplied by 2. Well, it'll just be I times 2. Same thing as well, but instead of mutating the vec, you can just return the new number. Oh, I have to do... num times 2, right? That's how that does it, because then it collects. With this, I think I need to do v.getI equals... It'll be and v.getI equals I equals v... Oh, what is it? It's... v.get I equals, for I in v eta, it'll be, I think it's like this. I'm not sure. It'll tell me what's wrong though, so it should be okay. That top one I'm not sure on. Yeah, that top one I'm not sure on. Integer. It shouldn't be a v, it should be an I. But that's not the issue that I was thinking of. And this should definitely be an I, obviously. But my problem is, it's iterating through v. It should be v dot something. Yeah. Ah, okay, let's have a look. I don't think that's the right way to do that, though. Does it need... I'm wondering if it needs... that. No. How does it want it? I is each element from the vec as they are being iterated. Can you try multiplying this? For the first function, there's a way to directly access the numbers stored in the vec using the... You can both access and write to the number that way. After you've completed both functions... Oh, I'm so dumb. It's... Ooh, it's I equals dereference of I times by 2, I think. The dereference and the actual reference of I might need to be swapped. Yeah, it needs to be swapped. They both need it. They shouldn't both need it. Oh, they both need it. Okay. Let me just try understanding why both of them need it. So you're getting I, which is the original value. You're dereferencing it from the... you're dereferencing it, then you're calling it again, and then timesing by 2. If you dereferenced it, you're making it mutable. Then you're calling an immutable version to times by 2 to store in the mutable version. You need to have both mutable versions to... Okay. I think that made sense what I just said. Yeah, that makes sense. For context, pointers and what's it called? It's just pointers in general are sometimes very confusing. It's like call by value and call by reference. Call by reference is using a pointer. Call by value is just using the memory address. These are using call by reference because you're referencing the place in memory. So you're getting the original value, right? You're getting the original value, which is on the right side. You're multiplying it by 2, and then you're storing it back in that memory reference. It's very confusing-ish. Basically, this one does it inside of the... Sorry, that was weird. Inside of the vector, while this one makes a new vector and returns it. What map does is it will allocate a new vector and then return... Sorry, it will generate a new object on that collect, right? So it'll do that multiplication of none times 2, and then collect it all into just one vector, basically making a new vector. So you'll have the original vector and then the new vector that you return, right? That original vector will get deallocated in memory, whereas this new vector will get a new memory space, right? Whereas in the original one, from vec loop, it mutates the original vector, which is why you don't need to handle any mutation in vec map, because you're just making a new one instead of mutating the old one. This is Move Semantics. I'm at 1 hour and 13 minutes, so I'm going to call it here. But we are at 24%. That is nearly a quarter of the way through wrestlings. I'm feeling better doing wrestlings now than when I was doing exorcism, because when I was doing exorcism, I was just looking at other people's code. So I can read Rust, like, fine, but writing it is not the best. At least now I'm getting used to just writing it. I do feel that as soon as I finish Rustlings, even though I will be able to write Rust, I'm still going to be going through the Rust road, because again, I'll still be able to read it. It's just gonna be that I won't be writing it, which isn't the best, but we'll see how it goes. Genuinely, if you have anything that's kind of similar to the koans for wrestlings, that like other wrestling koans that get you doing other things, like I was looking at the Rust books, and there's one on embedded systems, WASM, which is WebAssembly. What's the other one? There's the Nomicon, which is like unsafe memory access and memory allocation. If there are ones like that, kind of like Rustlings, but for those, please send them my way. I want to get better at Rust. I find Rust interesting, and I would like to get better. I have not done the Java koans, but I might give Java koans a try in the future. I'm currently working with Java, so I don't really feel like I need to do the Java koans, but we'll see how it goes. Anyway, thanks for watching. Like, subscribe, enjoy the rest of the day, and peace.